we shall have our topic as what? As mole concept. Now, mole concept basically deals with the calculations. Yeah? So we said we shall look at the moles. We said the mole is the simplest what? Calculation we shall see, which is grouping something. So we said moles group particles, what we call the Avogadro's number. Yeah? So we shall look at the formula masses. Those are the formulas, either of a molecule or either of what? A compound or an atom. Then we shall look at finding the mass, which we did. I think, yes, we did that. So we shall look volume, maybe of a given gas, heat changes. Then we shall look at the condition where we shall either look at either standard temperature and pressure or at room temperature as what? Pressure. So we shall look at also the empirical formula, molecular formula, and thermodynamics. So that is all a bit of what? Mole concept. So mole concept also has what you call the practical bit of it. We had forgotten it here. It has a practical part. So it has its own practicals. Well, we shall go to the lab and analyze all those. We shall see. Then the first thing we looked at was the, I think, formulas. So we said formulas we have mainly 3. We have the relative atomic mass for an atom, relative formula mass for a compound, relative molecular mass for a molecule. We said they don't have what? Units, because they are ratios. When you say a ratio, it is a division. That means the units are going to cancel out. Then we looked at the examples of molecules, atoms, and the rest. Oxygen is a molecule, so it is diatomic in nature. Hydrogen is a molecule, diatomic in nature. Chlorine is a molecule, diatomic in nature. Sodium, chlorine, those are atoms. Like when I say sodium atom, magnesium atom, those are atoms. Sulfur, it is an atom, yes, as it is. Then we said when we look at compounds, now that one will be now in terms of what? Either salts, like sodium chloride, sodium carbonate, those are compounds. So we said for that case, we shall use relative formula mass. So we have 3 things now. Relative atomic mass for an atom, relative molecular mass for a molecule, the relative formula mass for what? For a compound. So we looked at finding mass of different particles. So we said for every mole of an atom, it contains 6.2 times 10 power 23 particles. We said this number is a constant, what we call the Avogadro's number. So I don't want to deal so much in that, because we have few cases of that one. So for every, that means it is a constant. Either 1 mole of magnesium will contain those particles. Either 1 mole of magnesium sulfate will contain those particles. Then it is a constant, what we call Avogadro's what? Number. So the other thing we said, for every relative formula mass, relative atomic mass, it is always in terms of 1 molar. I mean 1 mole. That is when I say RFM, it is in 1 what? 1 mole. RAM, it is what? In 1 mole. Then we had the various examples. We said the atomic masses are this and those and that. I think I showed you a predictable yesterday, where we had the mass number and atomic number, but our main focus is now on what? On the mass number, because when you're finding mass, we use those atomic masses which are there. So we had some examples there. We said carbon is 12. So carbon is 12 grams, copper is 64 grams, sodium is 23 grams, magnesium is 24, aluminum 23. I think we saw those in a predictable. Then we said the way we write them, we state them, because they're in relative atomic mass. That means they're in 1 mole, and mass is weighed. You can't go to the shop and say, give me that. That means say, weigh for me 1 kilogram. Weigh for me 25 grams. Weigh for me that. You weigh the grams or you weigh the mass. I mean, now we shall say 1 mole of potassium. We always weigh 39 grams. Now, those ones we say they are first principles, the way we state them. We use what we call statements. Then you said 1 mole of sodium weighs 23 grams. Then we looked at also the compounds. In case I have maybe sodium chloride, the first thing you must know is to identify what the formula of sodium chloride is. That means you say sodium chloride has Na as sodium, then Cl as what? Chlorine. That means it contains the 1 sodium atom and 1 chloride what? Atom. But we saw from the masses up there that sodium has 23 times 1. Chlorine has 35.5. We say that chlorine, we get it from what? Its isotopes. Chlorine has isotopes of 35 and 30 what? 7. So the average of them will give us 35.5. Let me hope we are clear there. Are we good?
Yes. Yes.
Okay, I'm trying to give a review. So we got 58.5, but still here the same. It is relative. That means it's also in 1 mole. That means 1 mole of this compound will weigh these grams. Are there? 1 mole of those compounds is all those grams. So we continue to drive from where we said from 1 mole to 2 moles and the rest. So we went ahead, we looked at sodium carbonate. Now here, where we had 2 moles of maybe sulfur dioxide. Now that means we are running away from now what 1 mole something to 2 moles. So from there we are going to derive a formula. So we said from our formula, we realize that for the mass, I think we had a formula here. For the mass, this is the formula I said. For mass of a given compound, or the mass of a given atom, or the mass of a given molecule, it always equal to the number of moles times a relative formula mass for a compound, relative atomic mass for an atom, relative molecular mass for what? For a molecule. So we had trial numbers, which people did. People tried that. So people tried those ones, 4 grams and 7. Okay. Any question before we continue? Okay, we'll also look at the percentage composition. Any question? Any question?
Teacher.
Yes.
Help me and explain about percentage composition.
Okay. Now we said under percentage composition, we said for every, suppose I have maybe magnesium oxide. That's the formula of magnesium oxide also. That means I'll look for the mass of magnesium oxide first. That means mass of magnesium oxide. Remember, it has 1 mole of what? Of magnesium and 1 of what? Oxygen, isn't it? That means I have magnesium, 1 atom, oxygen, 1 atom. But the mass of magnesium from our periodic table, it is 24. Then oxygen is what? 16. That means when I add these two, I'll get 24 plus what? 16, giving us what? 40 grams. So that means this, remember, this is the compound. It is what?
Compound.
That means now it qualifies to say relative formula mass, RFM, which will give us what? 40, because we say they don't have units.
Yes.
Now they can tell us to find the percentage of oxygen. Are we there?
Yes.
That means oxygen in this formula here, the mass is only 16 because we have only 1 atom of what? Oxygen. I mean, now it will be what? It will be mass of oxygen, but the oxygen is only 1 there. That means now we just say just oxygen. Out of the mass of the total, which is magnesium oxide, times 100%. Are we there?
Yes.
So here we shall be saying, now we shall be getting mass of oxygen, which is 16 out of the 40 times 100%. So when you divide these two here, what do you get?
40%.
You You get 40%.
Yes.
Okay, 40%. So 40%. So that's how we get the percentage of what? Oxygen. If it was percentage of magnesium, are there? Percentage of magnesium, it could be mass of magnesium, which is 24, out of the total, which is what? 40 times 100%. What do you get?
60%.
60%. Very good. So that's how we get the percentage what? Composition from the mass. Any question?
No.
Okay. Now let us look at something new today. So we're going to look at converting from mass to moles. Converting from mass to moles. So subheading, today is 21. Today is 21. So my first day to write a date here, but I don't write dates. 20, is it 9th, 8th? What the date today? 29th.
29.
So 29th of the month is ending. 2021. So we're going to look at converting. So converting mass to moles. Remember yesterday we are looking at what? From moles to what? To mass. Now we look at mass to what? To moles.
More.
So let us look at one example and we see how do we look at such cases. Now, part A. Suppose you are converting maybe 240 grams of sodium hydroxide to moles. Are you seeing that? Now they've given us a formula of sodium hydroxide. That means the first thing you look for, since this one is a compound out there, we shall look for what? Relative formula mass, isn't it? That is step one. So step one, look for what? That means we know that sodium has a mass of 23. Oxygen has a mass of 16. Hydrogen has a mass of 1. That means this is now a formula, meaning we have one atom of sodium. I mean now it is 23 times 1 plus oxygen is also 1. So 16 times 1 plus hydrogen is also 1. So 1 times 1. That means I'm getting 23 plus 16 plus 1. What do you get?
40.
40 also. 40
Yes.
grams also. But remember, we said RFM has no units. That means don't put the what? The units. Just leave them in terms of what? 40 and so. But let me put an NB here. But we said for every RFM or RAM or relative atomic mass, they are always in 1 mole. Are we there? They're always in 1 what? 1 mole. That means 40 grams are in 1 what? 1 mole. Is that okay?
Yes.
So therefore, we shall be saying 40 grams of sodium hydroxide. We use statements, remember. Now we shall not say weighs, because we cannot weigh the moles. We shall contain the what? The moles. So we shall say 40 grams of sodium contains 1 what? 1 mole.
1 more.
Are we there? But how many grams have they given us? They have given us 240 grams. That means what of the 240? That means 240 grams of sodium hydroxide contains now to be 1 times the 240 out of what? 40. What do we get? But these are moles, remember, bracket, these are moles. So when you divide this,
6 moles.
6 moles, very good. That means the number of moles are what? Are 6. Have you seen the step?
Yes.
Step 1, you look for RFM first. Then RFM is in 1 mole. That means that mass you have got is in 1 mole. That means it contains 1 mole. What of the mass which is given to you? That is 240. So you're getting 6 what? 6 moles. Let's look at example 2. Example 2. Example 2. So example 2. So again, let's find the number of moles. Find the number of moles in 160 grams of oxygen gas. Have you seen that one? So step
Yes.
1. Step 1, do you know the formula of oxygen gas?
O2.
O2, very good. So that means oxygen is O2, but this one is a molecule, isn't it?
Yes.
It is what? It is a diatomic molecule. Are we there? It means it is now, we are going now to look at it in terms of what? Relative molecular mass. Are we there?
Yes.
But there are 2 of them. But we know that oxygen atom alone is 16. But these ones are 2, not so? It becomes, this one is going to be what? 2 times 16, giving us what? 32. Not so? But we said for every relative molecular mass is in 1 what? And this one is in 1 what? In 1 mole. Therefore, 32 grams of oxygen gas will contain 1 mole. Contains 1 mole. Are we there?
Yes.
Now, what of the
Yes.
60 grams that are given? That means now 160 grams of oxygen gas contains to be 1 times the 160 out of what? 32. Out of 31, 32. So out of 32, so bracket C, bracket, these are moles. Which answer do you get?
5 moles.
5 moles. So this is 5 moles. Very good. So are you seeing the steps? The steps C, first allocate. Which are we dealing with? Are we dealing with a compound? Are we dealing with a molecule or an atom? Okay, let us look at this one now. What if now they trick you now like this? Then I tell you, find the mass. Example 3. Example 3. Example 3. Example 3. Find the mass of, find the number of moles. Find the number of moles in, then they tell us 240 grams of magnesium atom. Of magnesium, just magnesium. Or they can tell us magnesium ribbon. Do you know magnesium ribbon?
Yes.
Magnesium ribbon is that coiled part in the lab. It is gray in color. So you try something that one now. Now, magnesium is an atom, isn't it?
Yes.
With the symbol what? Mg, isn't it? It means it follows now relative atomic mass. It follows relative atomic what? Mass, because it's an atom. What is the mass of magnesium? 12. What is the mass of magnesium?
24.
Very good, 24. Because from its notation, we have magnesium 24 up and 12 what? Down. But we take the mass number. Therefore, 24 grams will always be in 1 mole. So 24 grams of magnesium contains 1 mole. Are we there?
Yes.
What of the mass which is given? 240. 240 grams of magnesium contains so 1 times the 240 out of 24. What do we get?
10 moles.
10 moles. Very good. 10 moles. Very good. So now from that statement there, we're going to have a formula from that. We shall see that the upper things we hear, this one is mass given. This one is what? I think it's RFM or something like that. That means there are 4 number of moles. And now deriving a formula now. Therefore, the number of moles N, number of moles bracket N is equal to, so that means N is equal to the mass out of relative formula mass, or N is equal to the mass out of relative atomic what? Mass, or N is equal to the mass out of relative molecular what? Mass. Remember, we have 3 cases: a compound, an atom, and a molecule. Are we there? So all that's the same. But we don't use formulas. We use formulas in objectives. We don't use them in what? In paper 2. We use statements the way we freeze them there. So try for me this one now. Try for me this one. Try your number. Let me, any question before we go to try your number? Any question? No. Very good. So try your number. I think our mole concept is easy.
Yes.
But practice, people are scared of mole concept because they fear math. But when you take your time and analyze things step by step, they become easy. So try your number. Find the number of moles. Find the number of moles. Number of moles in Roman 1, 600 grams of nitric acid. Nitric. You are scared of, you don't know the formula of nitric acid?
Yes.
Nitric acid is the same as hydrogen nitrate. I'll give you a clue, which is HNO3, nitric acid. This is 600. Yes. That's part A. Part B, 250 grams of ammonia. Ammonia is a gas. Ammonia gas. Let me hope you know the formula of ammonia gas. Do you know the formula of ammonia gas?
No.
Ammonia gas. Ammonia is, Shamila, do you know the formula of ammonia?
Teacher, she's not there.
She has went off. Okay. She's there. Okay, but then maybe the microphone. Shamila, what's the formula of ammonia? Yes, formula of ammonia.
NH4.
NH4, that is ammonia. Ammonia is NH3. That's ammonia gas. These two things are different. When we say ammonia gas, it is NH3. Then ammonium is NH4. But you wanted ammonia gas.
Yes.
Then the last one, trial number. 100 grams of sodium carbonate. Sodium carbonate. Now the mass says they always give you, don't be scared that they don't give you. Hydrogen is always 1 mass, that's 1 gram. Nitrogen is 14 grams. Oxygen is 16 grams. They always give you those things, so don't get scared. When they're not given you, raise your hand, they will give it to you. Sodium is 23. Carbon is 12. I think those ones there, yes. So try for me those ones now. Are they coming out? On Saturday, we have a discussion of math online, paper 1 on Saturday. Let me hope we are all ready.
Yes.
You bring tomorrow. So on Saturday, we shall have a math discussion. So I'm going to send everybody a paper. Then I'll select numbers individually for this, and that, so that you come knowing what to discuss, isn't it?
Yes.
There's no ate mate, ate do, ate maimamu, ate orokosomunji, those things there.
Teacher,
Yes.
if you get like a point and it's like 9.5 moles, do you round off?
No, you maintain the 9.5. You maintain,
Yes.
because when you round off, the mass will change. When you round off, the mass will change. So just leave them the way they are. At least when you're rounding off, not over round off. Like 9.5 is okay. Don't round off to 10. Don't round off.
Yes.
Are they coming out? So what have you got on part A?
Teacher, me on part I've got 9.5.
9.5. Shamila, are you getting the same?
Yes.
Okay. So nitric acid. Nitric acid is what? NH3. So this is a compound, remember? So it follows relative formula what? Mass. So this one is 1. So 1 plus, this is 14 plus 16 times 3. So this is 15 plus, this is 48. So when you add here, that is 60 what? Is it 63? 63 grams. But you don't put the grams there because it's a unit, no? So I mean 63 grams of what? Nitric acid. Contains 1 mole. Contains 1 what? 1 mole. What of the 600 grams of nitric acid? So contains 1 times 600 out of 1, 63. So giving us 9.5 moles. Part B, what have you got? Let me help you. You have those steps there. Do you have those steps?
Yes.
Don't use formulas. I know formulas give shortcuts, but shortcuts are deadly. Shortcuts are deadly, isn't it? They taught me that one when I was young. Shortcuts are dangerous. Don't shortcuts to life. Suicide. Part B, what have you got?
Shami, I've got 14.7 moles.
14.7 moles. Shamila, are you having the same? Yes?
Yes.
Okay. Then part C, what do we have? Part C? Part C, what have you got? Part C? Yes, what have you got on part C? Yes, you calculating?
So we are still calculating.
Okay. Are we done? Are we done?
Teacher, where is go?
Taking long. Okay, let me wait a bit. So formula of sodium carbonate, I think that's the challenge. Yeah? Sodium carbonate, 100 grams of sodium carbonate. Part C was 100 grams of sodium carbonate. Yeah, let me wait for the formula. I'm waiting for people. What's the formula of sodium carbonate? Yes, Shamila?
Na2CO3.
Na2CO3. Very good.
CO3.
So then from there, the mass, it is a compound, remember? So it follows what? Relative formula what? Mass. So meaning if you come here, we shall say sodium, we have 2 of them. So times what? 23. Carbon, we have only 1. Times what? 12. Oxygen, we have 3 of them. So 3 times what? 16. So this one is 46 plus 12 plus 48. What do we get? What are we getting there?
83.
Are you sure? Are you sure?
No.
Patricia, yes?
106.
Yes, 106. So Shamila, look, maybe you missed something somewhere. Yeah? So 106, but remember it has no units.
Yes.
So this one is in 1 mole. 1 mole. Meaning now we have 106. So we have 106 grams of sodium carbonate contains 1 mole. Out there? What of the what? The 1 over 100 grams of sodium carbonate contains to be what? Be 1 times 100 out of 10 what? 6. These are moles. These are what? Moles. Very good. What do we get?
1.06